Time feels obvious until you try to explain it. We schedule our lives by it, fear losing it, and argue about whether it flows or just sits there. But when you poke at time with honest curiosity instead of fancy words, it starts behaving very strangely. Tonight, let's stop repeating what sounds smart and actually think about what time really is. When people hear the word time, they immediately imagine something flowing, something invisible but powerful, something that carries everything along with it. Yet the moment you ask what it actually is, the answers become vague and poetic instead of precise, and that is usually a warning sign. In physics, when something is real, you can point to how you measure it. Length is what rulers measure, temperature is what thermometers measure, and time, stripped of all romance, is simply what clocks measure. That sounds almost disappointing, but it is deliberately honest, because the biggest mistakes begin when we pretend time is more than the evidence allows. A clock does not sense a river of time passing through it. It simply repeats a regular process. A pendulum swings, an atom vibrates, a crystal oscillates, and we count how many repetitions happen between events. When you say something took 1 second, what you really mean is that a particular process repeated itself a certain number of times while that thing happened. There is no extra substance flowing through the clock to push it forward. The clock just changes, and we compare one change to another. This idea becomes clearer if you imagine a universe with no change at all. Nothing moves, nothing vibrates, nothing decays. In such a universe, asking what time it is would be meaningless. There would be no clock because there would be nothing that could serve as a repeating process. Time does not sit in the background waiting patiently. It only shows up when things happen. Change comes first. Time is the bookkeeping system we invented to keep track of that change. People often say time passes faster or slower, but that is a statement about clocks behaving differently under different conditions. A clock on a fast-moving spaceship ticks differently from one sitting quietly on Earth, not because time itself is confused, but because the physical processes inside the clocks respond to motion and gravity. Every clock always agrees with itself. It never feels late. The disagreement only appears when you compare two different physical processes after separating and reuniting them. This is where the idea of time as a thing gets people into trouble. They imagine a universal clock somewhere in the sky that everything should obey, and when experiments refuse to cooperate, they say time is behaving strangely. A better attitude is to say that clocks are behaving exactly as the laws of physics predict, and our expectations were sloppy. Once you drop the idea of a master time flowing everywhere the same way, the confusion reduces dramatically. The usefulness of defining time through clocks is that it keeps us grounded. Instead of arguing about what time feels like, we ask what actually happens in experiments. If two identical clocks are built the same way, treated the same way, and later disagree, then something physical happened to one of them. There is no need to imagine time stretching or squeezing like rubber. The clocks changed because the universe treats motion and gravity seriously, whether we like it or not. This perspective also removes the temptation to ask what time really is behind the scenes. Physics is not obligated to explain imaginary layers beneath what we can observe. If every prediction works by treating time as what clocks measure, then adding extra metaphysical machinery does not improve understanding. It only gives the illusion of depth without adding clarity. So when someone insists that time must be a fundamental substance, the sensible response is to ask how they would measure that substance without using a clock. If the answer eventually sneaks a clock back in through the side door, then the argument has gone in a circle. By staying disciplined and tying the idea of time to measurement, you avoid chasing questions that sound profound but lead nowhere, and you stay focused on how nature actually behaves when you test it carefully, because the habit of demanding operational meaning is what keeps thinking sharp and prevents us from confusing our language with the structure of the universe. People talk about the past and the future as if they were places you could visit or containers where events are stored. But the moment you try to treat them like physical things, the logic starts wobbling. You cannot point to the past and say it is over there. And you cannot open a box and find the future waiting inside. What actually exists are events and records. Something happens, and traces of that happening remain in the form of memory, photographs, scars, documents, or altered arrangements of matter. We then give a name to the collection of those records and call it the past, but that name should not be mistaken for a physical object. The present is even more slippery. Everyone feels convinced they know exactly what it is, yet no one can isolate it. The present has no duration you can measure without it immediately turning into memory. If you try to define it as a slice of time with some thickness, you have already smuggled in an arbitrary choice. Physics does not mark a special glowing boundary labeled now. The equations that describe motion, energy, and interactions do not pause respectfully for the present moment. They simply relate one configuration of the universe to another. The future is not sitting out there waiting to happen, fully formed formed and politely cued. It is a set of possibilities constrained by the current state of the universe and the laws that govern how states change. When people imagine the future as something real but hidden, they often confuse prediction with existence. The fact that we can calculate what will probably happen does not mean the future already exists in the same sense as a table or a chair. It means our models are good at extrapolating patterns forward. What makes all this confusing is the way the human mind works. We experience events in a sequence, and our brains are very good at stitching that sequence into a story with a clear direction. Memory accumulates in one direction, not the other. We remember breakfast, but not tomorrow's lunch, and from that asymmetry, we construct the feeling that time flows from past to future through the present. But this flow is a feature of our experience, not an ingredient added to the universe. Records play a crucial role here. A past event is something for which records exist now. Dinosaur footprints matter to us only because they left marks we can examine. If every trace of an event vanished, it would be indistinguishable from something that never happened. The past, operationally, is the set of present records that point to earlier configurations of the world. Remove the records, and the past loses its physical grip. This way of thinking also explains why debates about changing the past become so tangled. To change the past would mean altering all present records consistently, including memories, documents, and physical traces. Once you phrase it that way, the problem is no longer mystical but practical and overwhelmingly constrained. The difficulty is not that the past is sacred, but that the web of records is enormous and tightly connected. By refusing to treat past, present, and future as objects, you gain clarity. You stop asking where the future is located and start asking what the current conditions allow. You stop worrying about whether the present is real and start examining how perception works. This shift does not make time boring. It makes it precise. It keeps the discussion anchored to what can be observed, measured, and tested, and it prevents language from quietly turning metaphors into supposed facts that no experiment has ever detected. People often feel betrayed when physics refuses to match their intuition about time, but that sense of betrayal comes from forgetting where intuition comes from in the first place. Human intuition was shaped to help us survive at walking speeds, over lifetimes measured in decades, on a planet with fairly gentle gravity. It was never trained to deal with atoms vibrating billions of times per second, or objects moving close to the speed of light. Expecting the universe to respect those instincts is like expecting a microscope to be useful for looking at mountains. When physics describes time, it does so without consulting human feelings. The equations do not care whether something seems fair, simple, or comforting. If two processes behave differently under motion or gravity, the mathematics will describe that difference whether or not it agrees with common sense. When experiments confirm those descriptions, intuition has to move aside. Nature does not negotiate with expectations. This becomes obvious when considering simultaneity. People assume that if two events happen at the same time for one observer, they must happen at the same time for everyone. That feels so natural that questioning it sounds absurd. Yet careful measurement shows that observers in different states of motion can legitimately disagree about whether two distant events are simultaneous. This is not a trick or an illusion. It is a direct consequence of how signals travel and how clocks are compared. The universe does not provide a single universal notion of now just to make human conversations easier. Another intuitive idea is that time should pass at the same rate everywhere. A second should be a second, regardless of where you are or how you move. But physical processes do not agree to that rule. Clocks affected by speed or gravity tick differently, and they do so in ways that can be predicted and measured with remarkable accuracy. From the point of view of each clock, nothing strange is happening. It is only when we insist on a universal background time that the situation appears paradoxical. People sometimes respond to this by saying time itself must be bending or warping in a dramatic way. That language can be useful as a shorthand, but it easily misleads. What actually happens is that physical processes respond to conditions. Atoms, vibrations, and oscillations behave differently depending on motion and gravity. And since clocks are built from those processes, they reflect those differences. Physics tracks the behavior of matter and energy. It does not owe us a story that fits everyday metaphors. The deeper lesson is that physics is not designed to preserve intuition. It is designed to match experiments. If an idea feels wrong but works every time you test it, then the feeling is the part that needs updating. This is uncomfortable because intuition feels like understanding. Letting go of it can feel like losing solid ground. But real understanding often begins where intuition fails. This attitude protects us from forcing the universe into mental boxes that are too small. When we accept that our sense of time is a local, human-scale construction, we become open to discovering how time actually behaves under conditions far removed from daily life. The universe is under no obligation to be easy to imagine. It only has to be consistent, and it turns out that consistency is something experiments are very good at revealing, even when the results stubbornly refuse to match what feels obvious or natural. When people ask why time seems to move in one direction and not the other, they often imagine there must be some deep built-in rule that pushes everything forward, like an invisible conveyor belt carrying moments along. But when you look closely, the sense of direction comes from cause and effect rather than from time itself. We describe the world by saying one thing happens because another thing happened earlier, and that ordering gives structure to how we explain events. Without that structure, explanations would collapse into nonsense. Cause and effect are not philosophical decorations added after the fact. They are practical tools for making sense of what we observe. If you strike a match and it lights, you say the striking caused the flame. You never seriously consider that the flame reached backward in time to cause the striking. That is not because the idea is emotionally disturbing, but because it fails to line up with how information and influence actually propagate. Causes leave traces that effects can respond to, not the other way around. The laws of physics at a basic level are often indifferent to direction. Many equations work just as well if you run them backward, yet the situations they describe rarely do. That difference comes from the conditions, not the laws. When many particles interact, tiny details get dispersed into complicated patterns. Once that happens, reversing the process would require arranging all those details with impossible precision. The effect has happened, and the cause is no longer recoverable in practice. This is where time gets its arrow. Not from a ticking clock commanding the universe to march forward, but from the way causes generate effects that spread information outward. When a glass falls and shatters, the sound waves travel through the air, the heat dissipates, and the fragments scatter. Each of those effects carries information about the event into the surroundings. To reverse it, you would need all that information to reconverge perfectly. Nothing in the universe is set up to do that. Because of this, our explanations always point one way. We explain the present by referring to the past, never the future. That is not because the future is forbidden territory, but because it contains no records yet. You cannot use an effect that has not happened to explain a cause that already has. Explanation itself depends on this asymmetry. Without it, the very idea of understanding what happened would lose its footing. This also explains why memory works the way it does. Memory is a physical process that stores records of causes. Your brain changes in response to events, leaving traces that can be consulted later. Those traces are effects. There are no corresponding traces of future events because those effects have not occurred. The direction of memory aligns with the direction of cause and effect, and from that alignment arises the powerful feeling that time flows forward. When people say time could run backward, they often imagine the same causes producing reversed effects. But that picture quietly ignores the role of information. A backward-running world would require effects to consistently erase their own causes while still remaining understandable. That would make explanation impossible. You could not learn anything from experience because experience would not reliably connect actions to outcomes. So the direction of time is not enforced by a cosmic rulebook demanding forward motion. It emerges from the way causes produce effects and scatter information into the environment. Once you see that, time stops looking like a mysterious force and starts looking like an ordering principle tied to how the universe allows things to influence one another, how records are formed, and how explanations remain meaningful in a world where events do not politely undo themselves. The feeling that there is a moving present, a thin slice of reality sliding from the future into the past, is one of the most convincing sensations we have, yet it is also one of the least examined. It feels immediate and undeniable, which is exactly why it deserves suspicion. When you look for this moving present in the physical description of the universe, you do not find it. What you find instead are systems changing according to laws, with no special marker announcing which moment is now. The sense of now comes from how the brain handles information. Your brain is not a passive observer of events. It is an active system that continuously records, updates, and compares states. A moment ago, the brain was in one configuration. Now it is in another. That change creates the impression of motion, not in the world, but in awareness. The present feels vivid because the brain treats recent information differently from older information. Memory is the key to this process. Memory is not a storage of the past in some abstract mental space. It is a physical change in the brain caused by earlier events. Those changes persist, allowing the brain to compare what is happening with what happened before. The act of comparison creates continuity. Without memory, there would be no sense of duration, no sense of flow, only isolated impressions with no connection between them. This also explains why the present seems thicker than an instant but thinner than a long stretch of time. The brain integrates information over short intervals. It blends signals together to form a stable experience. That integration window gives the present its apparent width. It is not a fundamental feature of time. It is a feature of how biological systems process data efficiently. The future feels unreal because there are no memories of it. The past feels solid because it is packed with records. This asymmetry is often mistaken for a property of time itself, but it is really a property of information storage. A brain that could store information about future events would experience time very differently, but such a brain would require effects to exist before causes, which does not align with how physical processes operate. When people meditate or lose track of time, the feeling of the present can change dramatically. Seconds can feel long or vanish entirely. This is not time stretching or shrinking. It is the brain altering how it records and compares information. The clocks outside continue their steady rhythms, unaffected by attention or emotion. The only thing that has changed is the internal bookkeeping. Understanding this removes a great deal of unnecessary mystery. The present is not a privileged slice of the universe illuminated by consciousness. It is a label we give to the state our brain currently occupies, enriched by a fading trail of memories and expectations. The flow we experience is the continuous updating of that state, driven by physical processes that obey the same laws as everything else. Once you see the present as a constructed experience rather than a moving feature of reality, many puzzles dissolve. You no longer need to ask where the present was yesterday or where it will be tomorrow. Those questions assume the present is a thing that travels. Instead, each moment of awareness is simply the result of the brain interacting with the world, forming records, comparing them, and generating the feeling of passage from those comparisons. A feeling so persuasive that it convinces us time itself must be flowing, even though all the evidence points to memory doing the moving instead. People often think that confusion is a failure of understanding, something to be avoided or quickly patched over with confident words. But in studying time, confusion is not only unavoidable, it is necessary. Time touches every experience we have, so the brain builds shortcuts and assumptions around it very early. Those shortcuts work well enough for daily life, which makes them hard to abandon when they stop working. The first step toward understanding time is to recognize how much of what feels obvious is inherited habit rather than careful thought. When someone asks what time really is, the question sounds deep, but it often hides several different questions tangled together. Are we asking how time is measured, how it appears in physical laws, or how it is experienced by the mind? Mixing these leads to frustration. One part of learning is learning how to ask better questions. If a question cannot be tied to observation or experiment, it may be interesting, but it is not something physics can answer directly. Accepting confusion means resisting the urge to rush toward comforting metaphors. Images like rivers, arrows, or dimensions can be useful temporarily, but they can also trap thinking if they are taken too literally. The universe is not required to match the pictures we find easiest to imagine. When an explanation relies too heavily on imagery instead of testable consequences, it should be treated with caution. This attitude encourages patience. Real understanding often comes slowly after many wrong turns. You might think you understand time because you can recite a definition or repeat a popular explanation, only to discover that it falls apart when applied carefully. That moment of collapse is not a setback. It is a signal that you are finally pushing beyond memorization into genuine thinking. Confusion also keeps curiosity alive. If everything about time felt settled and intuitive, there would be no reason to investigate further. The strange features of time, its connection to motion, gravity, causality, and memory, remain interesting precisely because they resist simple stories. Each piece fits only when you are willing to adjust your expectations, rather than forcing the universe to fit them. In learning to live with confusion, you develop intellectual honesty. You stop pretending to understand what you do not. You become comfortable saying that a certain idea works mathematically and experimentally, even if it feels counterintuitive. That honesty is far more valuable than superficial clarity because it leaves room for improvement. The process of understanding time, then, is not a straight path toward a final answer. It is a discipline of continuously refining concepts, checking them against evidence, and discarding what does not survive scrutiny. The reward is not certainty, but a clearer sense of where the real mysteries are and where false ones have been removed. And that clarity, built on the willingness to be confused and keep going anyway, is what allows thinking to stay flexible, grounded, and genuinely connected to how the universe behaves rather than how we wish it would behave.